And we should be coming up live any second now. There we are. And mobile dashboard is live. I'm putting my audio through the that shouldn't go through the stream. No, I have that muted. Good. That would be a problem normally, but okay. Luckily, I don't think I need to listen to anything right now, so I just won't worry about that, and hopefully everything is working just fine. Okay, so we have audio is working, we have chat set up. It is 1 minute till 7. Right. So, good morning, everybody. We are continuing our Learning Rust sort of run through the book, walk through, read through, let's learn. I'm not really sure what to call the series besides the Rust book. Anyways, we finished chapter 11 last time, which was the lifetimes and testing, I believe. So those are pretty awesome to learn, but it's even more exciting for this week because we're beginning chapter 12, which is an IO project building a command line program. So I don't really know what program this is yet because I haven't really looked forward into the book. All I did was just see the title of it and got really excited. So without any further ado, let's begin. So, this chapter is a recap of the many skills you've learned so far, and an exploration of a few more standard library features. We'll build a command line tool that interacts with file and command line input-output to practice some of the Rust concepts you now have under your belt. Rust speed, safety, single binary output, and cross-platform support make it an ideal language for creating command line tools. So, for our project, we'll make our own version of the classic command line tool, grep. Globally search a regular expression and print. So grep is what is used to like search through files, but it can also search through standard input. In the simplest use case, grep searches a specified file for a specified string. To do so, grep takes as its arguments a file name and a string. Then it reads the file, finds lines in that file that contain the string argument, and prints those lines. Along the way, we'll show how to make our command line tool use features of the terminal that many command line tools use. We'll read the value of an environment variable to show the user how to configure the behavior of our tool. We'll also print the standard error console stream, standard error instead of standard output. So, for example, the user can redirect successful output to a file while still seeing error messages on screen. Stacking. Did you stream Friday? I couldn't make it and didn't see anything on YouTube. I did stream Friday, and that's a bit sad that it didn't come in. Let's make sure that things showed up. Hey, Miguel, I saw that there was and that reminds me, if we come to GitHub, there was a, right here, a response to your, oh, right here. So Jay Hagens responded to your comment, Miguel, or the information issue that you left, and so he left this code here about what types of cool things to do with lifetimes. Specifically, this is the craziest thing here, which is, okay, we're gonna we're going to initialize lifetime A and then initialize lifetime B, but we seem to be able to give it a type of lifetime A. So that way we're able to then assign their own lifetimes to each of them. So X gets a lifetime of A, Y gets a lifetime of B. That's exactly like similar to what we're seeing that the borrow checker does automatically when it's assigning lifetimes. But then we're able to say, you know what, no matter what, we're going to return a type with a lifetime of A, which is, of course, either of these, because B has a type of lifetime A. Didn't I say that 1.27, or was it Rust 2018, they'll have some major lifetime changes? I think it's soon. I don't know if it's waiting till 2018, and then I don't know if it's 21.27. I haven't looked too much into when the NLL is coming up. But anyways, I thought that was pretty cool and interesting. Okay, so we were coming and taking a look at our videos. Oh, take a look at that. Upload failed. Duplicate upload. So right here, part 40. Does it go through to the end? I am curious what we... Oh, no, don't want to go that far. It would have been... Nope, don't want that either. Okay. I want to see the README. Oh man, it's only skipping forward 5 seconds at a time. Okay, hold on. There you go. Currently at chapter 11, adding custom failure messages. So I don't think that I did properly upload that. So let me start that right now. I need to blank the screen for me finding the information for that. So just give me 1 second. I keep the information for what I'm going to in Google Keep, but I have a whole bunch of other stuff in here too that I don't necessarily want to show up. Here. Let's try this again. Video producer. Oh, well, so like A extends B or the other way around. So either lifetime A is chosen or lifetime B, but B is at least the length of A. Not sure how to explain. Yeah, I'm not. It does seem really interesting. What we're seeing there, and yeah, I am not completely sure how to explain that either, unless we're saying like, hey, A is the same properties. No, B has the same properties of A, which means essentially they're the same. Okay, and the description part of it, tags, Rust, lang. What else should I put in here? I think I can close that. And now I can reactivate you. Okay, so tags rust lang testing. Public, start the export. So we'll see how this works. It usually takes about an hour or so for it to export out there, and then render the video and everything else it needs to do. Hopefully it won't detect that it's a duplicate. What I can do is it called highlight? I can highlight the entire thing. Play you. So highlight the rest book testing. So I could just say rest book chapter 11 testing under creative, and we're just going to make it the entire stream. Okay, so we'll then new highlight. Describe and save. Not really sure what this is on the left. Description. Okay, so this is the Rust book, creating this highlight case, export to YouTube. Doesn't work. Okay, so some of your highlights have failed to save. Why? Does it not like that word? Does it need tags? It's not like a comma? Rust. Okay, I don't know. I'm not going to spend too much time on that. That's kind of annoying. Well, I try to create a... Yes, I wanted to leave the page. Okay, so continuing on, we're going to just get back to this. So where were we? One Rust community member, Andrew Gallant, has already created a fully featured, very fast version of grep called ripgrep. By comparison, our version of grep will be fairly simple, but this chapter will give you some of the background knowledge you need to understand a real-world project such as ripgrep. Our grep project will combine a number of concepts you've learned so far. Organizing code, using what we learned in modules, so putting stuff in libraries, I believe. Using vectors and strings, handling errors, using traits and lifetimes where appropriate, and writing tests. We'll also briefly introduce closures, iterators, and trait objects, which chapter 13 and 14 will cover in detail. All right, so beginning, accepting command line arguments. Let's create a new project with, as always, cargo new. We'll call our project Minigrep to distinguish it from the grep tool that you might already have on your system. Okay, so this is also another really good point, which is I believe that that Rust has updated since the last time we've used it. Because if I do Rust C -B dash version. We're using 126.0, and I believe that 126.2 has come out now. So let's try Rust. Rust up. Is it just Rust up update? Yeah. And this will get us to, oh, apparently Rust version 1.27. Okay. So a full major update for this. Boy, and of course now it's going to be slow as it downloads. Installing component, Rust standard, cargo. Of course, the first one was Rust C, so that's a good one to have. The actual compiler itself. All right, syncing channel for the nightly. And to add on, stacking what Miguel is saying is, I believe, sort of reading through the NLL stuff, I believe that it's more of, it's going to make more decisions on its own. Like, it's going to make better guesses as to when to put the lifetimes in, so we won't have to manually annotate with lifetimes quite as often. But it won't be perfect, so therefore it won't, we'll still have to do it sometimes. The real question is, when is it going to land though? All right, so we have the new Rust. If we look, 1.27.0. So let's do this. Cargo, well, we want chapter 12, right? So take chapter 12. Then we'll Rust cargo new. And what are we going to create? Minigrep. And let's open up VS Code here. Okay, so that I noticed that they're still, like, in the book they're like, okay, we'll put the -- binary on in order to like truly distinguish it, but it's by default it creates a binary. Is that a real Linux command or is that a bash alias? Take is a bash alias, because if I do like which take, it's, I mean, I guess it's a bash function that I get for free because I installed omizsh. All it really does is just make a directory and then cd into it. The first task is to make Minigrep accept its two command line arguments, the file name and a string to search for. That is, we want to be able to run our program with cargo run, a string to search for, and a path to a file to search in, like so. So cargo run, search string, and then the file name. Right now, the program generated by cargo new cannot process arguments we give it. Some existing libraries in creates.io can help with writing a program that accepts command line arguments. But because you're just learning this concept, let's implement this capability ourselves. I like that more, that we're going to do that ourselves. Reading the argument values. To enable Minigrep to read the values of command line arguments we pass to it, we'll need a function provided in Rust standard library, which is standardargs. This function returns an iterator of the command line arguments that were given to Minigrep. We haven't discussed iterators yet, we'll cover them fully in chapter 13, but for now, you only need to know two details about iterators. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector, containing all of the elements the iterator produces. We have used those though. Use the code in listing 12.1 to allow your Minigrep program to read any command line arguments passed to it, and then collect the values into a vector. So I noticed that instead of going to full args, we're just using standard env, so we can just use env dot, env : args. So that args equals that we're correcting a vector of strings, and then we're getting env args. We run that. That gives us the result is just a string, I'm guessing, that we then collect, and then we're going to print line what these are. So let's go ahead and do that. So in source, main rs, use standard env, and okay, so our first thing that we want to do is bring in the args into a variable. So because I'm curious about what it looks like right now before we run the iterator over it. So let args equals, it's going to be env args, and let's just do that, and then we'll also print line args. Save. Thank you. I will not do that right now. And cargo run. Cargo run hello world. So we'll give it 2 arguments. It cannot be formatted with a default formatter. So let's try debug form. Okay, so args, it looks like a structure of some kind. It has an inner key, which has then target bug Minigrep. So that's the program that we called it. It's like this is the program itself. Hello and world. So perfect. So we want to then collect these into, because what we're seeing that they're doing is they are just able to straight up collect it. So if we do that, now we can't do this without also telling it what the type that it's coming into. So that's where we say, hey, let args is going to be a vec of type that. Now if we run this, now we just have a plain old vector which has this is the full source of where the binary is that we called it, and then hello and world. All right. First, we bring standard env model into scope with a use statement so we can use its args function. Notice that the standard environment args function is nested in 2 levels of modules. As we discussed in chapter 7, in cases where the desired function is nested in more than one module, it's conventional to bring the parent module into scope rather than a function. By doing so, we can easily use other functions from standard env. It's also less ambiguous than adding use standard env args and then calling the function with just args, because args might easily be mistaken for a function that's defined in the current module. Yeah, I could see that. The args function and invalid Unicode. Note that the standard env args will panic if any argument contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard env args os instead. That function returns an iterator that produces os string values instead of string values. We've chosen to use standard env args here for simplicity because os string values differ per platform and are more complex to use than with string values. I guess I promise I won't use anything other than valid Unicode when I'm searching. On the first line of main, we'll call env args, and we immediately use collect to turn the iterator into a vector containing all the values produced by the iterator. We can use the collect function to create many kinds of collections, so we explicitly annotate the type of args to specify that we want a vector of strings. Although we very rarely need to annotate types in Rust, collect is one function you do often need to annotate because Rust isn't able to infer the kind of collection you want. Finally, we print the vector using a debug formatter, : ? Let's try running the code first with no arguments and then with 2 arguments. So, yep, we saw that we got these. Notice that the first value in a vector is target debug minigrep, which is the name of our binary. This matches the behavior of the arguments in list in C, letting programs use the name by which they were invoked in their execution. It's often convenient to have access to the program name in case you want to print it in messages or change behavior of the program based on what the command line was used to invoke the program. But for the purpose of this chapter, we'll ignore it and save only the 2 arguments we'll need. Specifically, that's really good for logging because sort of like a fun thing that can be done, and like if a hacking tool is aware that you're doing this, obviously they can just mimic that. But what you can do for your tool is just say, hey, we're going to log when we're used to the output logs. We're going to put where exactly we're called, like what our path is. And then we're going to put any of the logging output. Because what somebody can do is go in there and inject a little piece of code that is named the same as yours ahead in the path, and therefore they'll get executed first. But they may not put that into their logging value, so that you have a small chance that you'll say like, hey, wasn't I supposed to put like the location of where it's being executed? Saving the argument values in variables. Printing the value of the vector of arguments illustrated that the program is able to access the values specified as command line arguments. Now we need to save the values of the 2 arguments in variables so we can use the values throughout the rest of the program. We do that in listing 12.2. So file name, source main. Okay, so center B. So here we're collecting. So we're able to now just say, hey, we want to grab out like our query and our file name into specific different sections. Let's go ahead and do that. So in here, we're going to say, so the first one is going to be the query equals, I guess we just need a reference to args position 1, because position 0 is the path of the binary, and let file name is going to equal, and we're going to get a slice of args position 2. And then we're going to change our print line, say, okay, we are searching for blah in blah. So now it's going to be query file name. Let's go ahead and run this. So hello world, we are searching for hello in world. As we saw when we printed the vector, the program's name takes up the first value in the vector at arg0, so we're starting at index 1. The first argument Minigrep takes is the string we're searching for, so we put a reference to the first argument in the variable query. The second argument will be the file name, so we put a reference to the second argument in the variable file name. We temporarily print the values of these variables to prove that the code is working as we intend. Let's run this program again with the arguments test and sample text. Got that? Great, the program is working. The values of the arguments we need are being saved into the right variables. Later, we'll add some error handling to deal with potential erroneous situations, such as when the user provides no arguments. For now, we'll ignore that situation and work on adding file reading capabilities instead. Reading a file. Now we'll add functionality to read the file that is specified in a file name command line argument. First, we need a sample file to test it with. The best kind of file to use to make sure Minigrep is working is one with a small amount of text over multiple lines with some repeated words. Listing 12.3 has an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your project. Enter the poem, I'm nobody. Who are you? All right, so I think I can just copy this text here. We're going to create poem.exe. So we're going to cat to xt, paste that in there, and perfect. With the text in place, edit source main.rs and add code to open the file as shown in listing 12.4. So before I take too much time on that, let's try it. So I can't remember exactly what open is off of. It's like use standard. Is there like an FS? Not really an open there. There's like create directory. Oh, there's file. Oh, is it standard like file? Standard IO. Oh, that's for like standard in. So we're going to use that for standard in and send out an error. Okay, so that's not the one we want. Format, let's see. Just looking through this to find the one we want. Ops. I think, do we try OS? No, definitely not that one. Is there a file? Not seeing that off the top of my head. So let's go searching for that. So we're gonna see Rust open file. Like where is that? Standard FS file. Oh, okay, and then we do file open, because then we can just do file create, file open. So that's what we want. So standard FS file, like that. So then once we have these, the idea, what are we supposed to be doing again? We are with the text in place, edit source main.rs and add code to open the file as in here. So we want to essentially do this. The mute file equals file open, hand it the text. I noticed that they're using the question mark operator here. So if we were going to do that, we'd have to also return a result with an empty result, or we can just do our expect. Then we can get this and read it, and then print those contents to a string. So let's do this. We'll first get let mute file equals file open, and it's going to be path, so that'll be the file name, and then dot expect, and our expect, we're just going to say error opening file. Okay, so that's us opening this file, and then if we want to read it in and print the contents to the screen, we also need to create a brand new string, which is mutable because we're going to be handing it to a function that will update it. So let content, maybe I'll do file content equals a string, new empty string there. Then we're going to file read to string and pass it a mutable reference to the contents. So then we'll say, okay, file read to string. I don't really see a difference in here. And we're going to pass it a reference to the mutable reference to the file content. And then we have an expect, which is error reading file. No method name reads a string found for type standard FS file in the current scope. Okay, so what happened? File is here. File read to string. That is the one we're doing. And then we should be able to print out this file. Okay. We're searching for this, and then we can add in print line. You need to bring prelude into scope. Isn't the prelude like bring it into scope automatically? File contents. File content. No method name read to string found for type standard FS file in the current scope. Items from traits can only be used if the trait is in scope. So we need to bring in standard FS. Okay, let's run this because I believe that it gives us, if that's true, then it's gonna get, See, I still have a poem. Nope, I destroyed it, no! Okay, hold on. I still added my paste buffers. That's not terrible. Okay, so let's cargo run, and let's get this error message, and it should tell us use standard IO read. That's what we need. Then it should make that, yep, go away. Thread main panicked at error opening a file on OS. Oh, I need to actually tell it that it is poem.txt. So that's not bad. Oh, so what was it? Error opening the file. Kind not found. Panicked at error opening file. Okay, so it did give my message. That's really awesome. So we need, that's just a me problem. So instead of word, we're gonna do poem.txt. And then here we go, running. We're searching for hello and poem.txt, the file contents, and then it's the poem. Perfect. So let's see what they did. We're doing, let's see, standard FS file, standard IO prelude, and then everything. I guess they're doing this that you don't have to worry about it. Whereas mine is being more specific of like, this is the exact thing I want, and then I'm continuing to add those in. Function main, print line, in file, file name. Oh, I was gonna say like, I missed the snip. So all the previous code is up there. So we're still getting the file name, then mute f equals the file open, then we're expecting file not found, let mute contents, string new, f read to string, mute contents, expect something went wrong reading file, then print line with text, \n, contents. Perfect. First, we add some more use statements to bring in relevant parts of the standard library. We need standard FS file to handle files, and standard IO prelude contains various useful traits for doing IO, including file IO. In the same way that Rust has a general prelude that brings in certain types and functions into scope automatically, the standard IO module has its own prelude of common types and functions you'll need when working with IO. Unlike with the default prelude, we must explicitly add a use statement for the prelude from standard IO. the standard IO prelude, and then everything. So we can, so I don't need this one because I could just use standard IO prelude. Oh, interesting. So it's buff, read, seek, and write. But I'm just going to bring in everything. Let's see. In main, we've added 3 statements. First, we get a mutable handle to the file by calling the file open function and passing it the value of the file name variable. Second, we create a variable called contents and set it to a mutable empty string. This will hold the content of the file after we read it in. Third, we call readToString on our file handle and pass it a mutable reference to contents as an argument. After those lines, we've again added a temporary printline statement that prints the value of contents after the file is read, so we can check that the program is working so far. Let's run this code with any string as the first command line argument, because we haven't implemented the searching part yet, and the poem.txt file is the second argument. All right, so let's take a look. Oh yeah, then we're just running it and we get exactly what we got. Did it? Great, the code read and then printed the contents of the file. But the code has a few flaws. The main function has multiple responsibilities. Generally, functions are clearer and easier to maintain if each function is responsible for only one idea. The other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem. But as the program grows, it'll be harder to fix them cleanly. It's good practice to begin refactoring early on when developing a program because it's much easier to refactor smaller amounts of code. We'll do that next. Awesome. Refactoring to improve modularity and error handling. To improve our program, we'll fix 4 problems that have to do with the program's structure and how it's handling potential errors. First, our main function now performs 2 tasks. It parses arguments and opens files. For such a small function, this isn't a major problem. However, if we continue to grow our program inside main, the number of separate tasks the main function handles will increase. As a function gains responsibilities, it becomes more difficult to reason about, harder to test, and harder to change without breaking one of its parts. It's best to separate functionality so each function is responsible for one task. This issue also ties into the second problem. Although query and file name are configuration variables to our program, variables like f and contents are used to perform the program's logic. The longer main becomes, the more variables we'll need to bring into scope. The more variables we have in scope, the harder it will be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. Refactoring after 3 lines of code. How cute this book. How cute this book must not have project managers. Yeah. Although, so what I've done in the past that's worked really well is just don't report it done until after refactoring. And that's, if you have a project manager who has been a developer before and believes in clean code, then they'll definitely they'll be on your side for that, and you can be completely open with everything that you're doing. If your project manager doesn't know code or doesn't believe in like that sort of clean code and it's like, let's get these out the door fast, then the onus becomes to us to either educate them or do it regardless. Usually like a method of both. I have convinced even agencies before to get into like test-driven development because I just did it. I put that into my my time estimates, so that way it was done, and I reported it done when the tests were done, and that way when later on things broke, I was like, oh look, I have a bunch of tests that tell me exactly where the code is broken. Let me just go fix them. It'll take less than a day. And that was pretty awesome. The third problem is we've used expect to print an error message when opening the file fails, but the error message just prints file not found. Opening an error can fail in a number of ways, besides the file being missing. For example, the file might exist, but we might not have permission to open it. Right now, if we're in that situation, we print the file not found error message, which would give the user the wrong information. Fourth, we use expect repeatedly to handle different errors. And if the user runs our program without specifying enough arguments, they'll get an index out of bounds error from Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place, so future maintainers had only one place to consult in the code if the error handling logic needed to change. Having all the error handling code in one place will also ensure that we're printing messages that will be meaningful to our end users. Let's address these 4 problems by refactoring our project. Separation of concerns for binary projects. This organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. As a result, the Rust community has developed a process that uses a guideline for splitting the separate concerns of a binary program when main starts getting large. The process has the following steps. Split your program into a main RS and a librs and move your program's logic to librs. Well, that one's like pretty obvious. As long as your command line parsing logic is small, it can remain in main RS. Otherwise, I assume move that also to librs. When the command line's parsing logic starts getting complicated, extract it from main RS and move it to librs. The responsibilities that remain in the main function after this process should be limited to the following: calling the command line parsing logic with the argument values, setting up any other configuration, calling a run function in librs, handling the error if run returns an error. This pattern is about separating concerns. Main RS handles running the program, and librs handles all the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all of your program's logic by moving it into functions in librs. The only code that remains in main RS will be small enough to verify its correctness by reading it. Let's rework our program by following this process. Extracting the argument parser. We'll extract the functionality for parsing arguments into a function that main will call to prepare for moving the command line parsing logic to source librs. Listing 1215 shows the new start of main that calls a new function Parse Config, which we'll define in source main RS for the moment. So we're just, okay. Interesting that we're putting that in more, like putting this function in source main RS. But the biggest thing that I was sort of looking here is they're still collecting this into here, but they're throwing this into a vector, but they're grabbing, okay, query and file name. This looks like they are destructuring it out of whatever parse config returns. So let's go ahead and implement that. So if we were to kind of want to just put this into a library on its own right now, and then we can do test-driven development because we can't do that right now in main. So let's go ahead in source. We're going to create a lib.rs file. I'm going to go ahead and create it in here, even though they might have us move it to different files. So we're going to do a pub mod a public module. What are we going to name this? This is going to be like parse. Oh, I think we named these capital, don't we? Modules? Actually, don't remember anymore. I think we do. Public mod. I'll just use those right now. Parse input. And then we're going to have a public then we're gonna have this. I can't remember what this is, so let's go look it up. Rust library test. This is the code that we're looking for. Okay, so we get the config test test. This will tell Rust that when we build it after, when we build this, when we build the entire project into a binary for production, it will not include these lines in there. So otherwise we could put the test directly in the module. Okay, so mod tests, it's a test, and we're just gonna say, okay, it works. So parse standard in, that's all I'm gonna do. So this is the happy path for this. What we're going to have to do is use and bring in this function here. So I cannot remember, do we need to do a use with it? I think we do. Oh, right, we need to use the super thing. Use. So you're weird. Yeah, there we go. Use super. That. Oh, but it's not just super like this, it's super parse, right? Parse, like that. So now I could just run these functions directly. Although what I might want to do is just bring in parse, and then I can say, okay, parse colon. So let we'll have the query and the file name, and that's going to become equal to parse and parse input, and we're going to pass in. What are we going to pass in? Well, we also need to sort of like mock up and pretend we have the actual thing. So that's going to look like a vector with 3 items in it. So let sort of like a standard in. This is going to be vec of like hello world. It's, what was it before? It was target debug minigrep. So for example, it would be target. I guess this one doesn't really matter because we could just say like hello world. This one does matter because then we're gonna say, okay, this is gonna be our query. So our, and this one's gonna be file name. So we do that, then we come into here and we're going to pass in, we could just give it maybe a reference to this vector. And what we want to do is get an output of this query and file name. Although in reality, we don't really care if we lose the vector. But then again, we don't want it removed from memory because these things would then not exist anymore. Because these are references as well, because I didn't make them into true strings. So we do this, and now we want our assert. So assert equal, and it's going to be the query, the query is equal to standard, and I could actually just say, okay, well, this should be our query. And assert equal our file name is equal to the file name. All right. So, like in two red, yellow, green convention, let's go ahead and run our tests. Cargo test. So, not found in parse. So, perfect. We're beginning with a red. So, function parse input. And we know that this is taking in a standard in, so it's going to be a reference. It's going to be input, which is a reference to vector, right? A reference to a vec, which is string stirs, and then we're going to return a reference to a stir. And there's that. Do we get any errors? No errors yet, so let's go ahead and run our test again. So here's this cargo test, and so now we get, okay, function parse input is private, so we need to, it's public. The trait bound standard string standard marker sized is not satisfied. The string does not have a constant size node at compile time. Or which one? The end of here. So public function parse input might need to be a reference to vector and a reference to vector and a reference to the string within the vector too. Okay, now it needs now expected the lifetime parameters. Because we're returning a borrow here, we need to now set these. So what is that? That input. Where do I put? It's right here, right? Do we need one here too? Like, is this also a lifetime? Probably. Okay, so mismatch types. Expected a reference, found absolutely nothing exiting out. So perfect. So now we're getting to the point where this function is actually attempting to run. It expects a reference coming out. And so if I was to say something like, okay, input of 1, and I just return that, how does that work? Okay, so mismatch types, expected string, found tuple. So hold on. Let a tuple of query and file name. Interesting, I would have expected that they would have been reversed around. You're right, I am. It is 2 minutes till 8. Thank you, Stacking. I was getting a little bit far, lost into this and having fun just fighting myself on this one. This is a fun pattern of programming. It's sort of like the hostile tester, the hostile developer, where you write your tests and then you do the bare minimum before running your test again to see if you can get away with doing that. And that's how you can write your tests to make sure that they're covering, even in a happy path, what you really need, what you really want it to do. So because it is 1 minute till 8, I'm gonna leave it right here. But what's really cool is that when I run this again tomorrow, we're gonna know exactly what to do, because our errors are gonna be telling us, hey, this is not cool. So let's go ahead and update our README. So we're in chapter 12, but we are now in a different URL for this. We're in test the mod. Oh no, that's the wrong one. Is this one, extracting the argument parser? Right there. We'll save that and back to here. And we're gonna send all this stuff up, which is beginning creating Minigrep project. And I'll send that on up. So it's in GitHub in case anybody wants to take a look at the code. Interesting approach to these tests is this what they call test driven. Not an actual programmer. Yes, this is test driven, where you write the test first and then you write the code. And if at any time you realize the tests need to be updated, you update the tests first, not the code. That way you know exactly when to stop writing the code because the test passes. If there's still more code that you want to run, but the tests are passing, that means you need more tests. The benefit from that doesn't come until much later in the project. It's a very fascinating theory of development. But with that, I think I'm good. So thank you everybody for stopping by and watching. I'm doing this every single morning at 8 a.m. Oh, I'm getting all my notifications for 8 a.m. At 8 a.m. Mountain Time here on Twitch. I'm also publishing these as archives to YouTube. I have links to my YouTube channel. I have links to my Twitter account and my GitHub in the stream description. Or if you're watching this VOD on YouTube, I have it in the video description. So if you'd like to get notifications when I go live, please follow me here on Twitch or YouTube or Twitter, or all of the above. With that, I am gonna go and get on with the rest of my day. And Miguel, yeah, you said you're not an actual programmer. I don't know. I would hesitate to agree with that. That really awesome, as Stacking said, that really awesome big lifetime write-up that you wrote, that feels like what a programmer would write. So maybe you're not being paid yet to be a programmer, but you're a programmer. You're one of us. But with that, I will see you all tomorrow. Have a great rest of your day.